Packages, as we discussed, facilitate logical grouping of items based on functionality or need. For example, you might want to create a package consisting of procedures and functions related to order management, like creating, modifying, or deleting orders. Or maybe to keep all the constants used in your system in a separate package. Or to create a utility package to keep all the general purpose utility subprograms. The variables, constants, etc., which you define in your package specification are visible to all other packages, procedures, functions, and anonymous blocks in the system. This global visibility allows you to define these constants or variables once centrally and then to refer to them from different client applications. Along with providing global visibility, Oracle maintains the state of the data for the variables, collections, etc. declared in the package specification for the duration of the session, allowing you to maintain your session data without any other session being able to see and modify it. Some of you coming from Java or C# background know that it takes some effort to achieve thread-safe data, which is provided easily in Oracle database using package specifications. Package specifications are like interfaces in Java or C#, exposing public APIs available for other clients to consume. However, using package bodies, you can create additional private subprograms available only to the other members of the package. So it gives you the ability to selectively expose only the functionality relevant to other clients and hides from public view what is not needed to be exposed or should not be exposed. You can create package specification consisting of public APIs without having to define their implementations right away. So from a design perspective, it gives you the flexibility of architecting your code and APIs without worrying about the fine implementation details right away. Packages like procedures and functions are named program units. So they have all the benefits of a named program unit where they are compiled and stored in the database and can easily be reused. Packages allow for further performance optimization in that when you reference a package for the first time, Oracle pulls all the member subprograms into memory at the same time, preventing further disk IOs for subsequent uses. When program units call each other, they create dependency links, causing the dependent program units to be invalidated and recompiled every time a referenced program unit changes. However, in the case of packages, if you do not change the public APIs, you can change just the implementation in the body without invalidating the consuming clients, another additional benefit of using packages. There are not many instances when you should not use packages and should create standalone procedures or functions instead. The only instance I can think of is when the specification is constantly changing. In other words, the business needs require you to change the name or the subprogram parameters or add or remove subprograms constantly. As soon as you make the change in the specification, Oracle will immediately mark all the client programs, referencing them as invalid, and will try and automatically recompile them the next time they are called. So say in the package specification, we have two procedures A and B. Procedure A's definition changes frequently and B is relatively steady. So even though procedure B does not change, all client applications referencing it would be marked invalid and recompiled every time procedure A changes. In such situations, it is better to pull out the frequently changing subprogram A out and create it as a standalone procedure. You should only keep the subprograms whose definitions are relatively steady as a part of a package specification. You can still continue to modify the implementation or the body for these package subprograms, as just changing the body or the implementation does not cause the invalidation of the dependent units.